Yo, welcome. It's Dr. James Utley, your resident codebreaker data scraper. And I want to demonstrate my final project, or the first draft, early stages of my final project. And I want to keep it brief. So what that means is, let me get you up to speed. First off is I've built a molecular dynamics engine in Rust. It's called Gumol. So it basically simulates an acute radiation environment or a downstream radiation or a downstream oxidative stress environment in truth. Secondly is I wanted to be able to correlate that with a wet lab, right? So what is interesting to me at this point, which I still have a lot to learn, is the Nuclera system. The Nuclera system is a MicroDrop, a microfluidics system that, from what I can understand from the documentation, is you could build a different wells or a pattern of wells and then test the oxidative stress environment. And so I started building an application which then kind of mimics what is required for the configuration of that system. And then so in hopes as I'm refining the functionality of the Gumol MicroDrop, that I can then provide a client so I can export the files, and that's just how I'm understanding it from what's available online. Okay, so first off, let me just orient you to this section here, which is the simulation import. So the backend is written completely in Rust, 100% in Rust, because I'm a Rust dev, amongst other things. Okay, so it's written completely in Rust, and I'll just go through a quick walkthrough so you can see like what the application is about. So again, this is a wet lab microfluidics high throughput correlation that should correlate with, or not should, but is a way to test correlation between my visualization simulation engine, my molecular dynamics simulation engine, and then a wet lab component to gain insight. And that's really all you can kind of say at this point. So anyway, without further ado, let's start walking through this thing. Okay, so first off, this is the MicroDrop, and it has an import, so I can import, what I have imported right now is a simulation file. So as you can see, it's a Gumol oxidative stress, and so it has these ROS species. This is the time point, the temperature, the damage threshold, and these are all items that I grabbed from the documentation of the Nuclera system. So what we're going to do is we're going to move on to the next one. So then it gives you the card configuration. And I haven't seen this thing, but I've only seen like what's available on YouTube and everything of how these cards are formatted. And I can definitely change this experimental card. I can change the wells, the positioning, all of this stuff. But I wanted this to be kind of a centerpiece. So you can pick your ROS or your oxidant species here, and then you can change your color mode, your exposure times. You can add the time, short duration, long duration, your treat, and I just tried to, so you got your control, you got your SOD3, which is the extracellular superoxide dismutase, which is really what I'm trying to test in this radiation environment. And then you can rename and you have a catalyst, and so rename this. So that's where it's at right now. So this is definitely just a framework, because as I learn more and make it through the weeks of the cloud automation, like this hopefully will become very clear and very easy to use. Okay, so there's a parameter map. You can translate the ranges here. So you can have like the diffusion coefficient, so the droplet mixing ratio. So that's like trying to test your specimen. And this, in my case, I would like to test the overexpression of a mesenchymal stem cell or stromal cell. That's what I do, and I have published a paper in Aerospace Research Central that kind of outlines the grand aim of the project, and which also is in the 3 aims that I have to do. Okay, so again, this is for how to grow almost anything 26, and it is really a basic. This is early stages. So then I can develop the matrix preview, and if you see that it has the ID, the oxidant, the antioxidant, time, and such in this matrix here. So I can generate this matrix, and it has this 40 droplets from the simulation data. Now I'm going to move over to the Nuclera config. So this is what I gathered from their website of the config file and how I would do that. May not be accurate, but it will be by the time. So you have your wavelengths and your exposure, and then you can generate your Nuclera config, which we did here. So it intakes this YAML file, so it'll export the YAML file. But just moving forward, so the readout is the fluorescence at 520 nanometers, 10 seconds, and this is the exposure time. And here it's all the volume, the mixing cycles, etc. Like everything you would theoretically kind of need to run this experiment. Okay, so then the protocol generator. So this generates a protocol of like what you should do. So here's your equipment, here's your reagents. You have your ROS fluorescent probe procedure, 1 through 6, gives you kind of outlook. All right, and then you're going to move to So you can export this protocol, or you can export it in Markdown, and then boom, here's the data. So I just kind of like ran this, but let's like run the correlation analysis. And so it runs the correlation analysis, and this is all the simulation data, but so it's like a prediction versus measurement. Oh, there's a bug here. I need to fix that formatting. And then you can outline out. But this is, I just wanted to walk through, and it, you can export this data table. So I just wanted to walk through this so you can see what it is. Right? So there's one stages, how to draw almost anything, 26. And down here you have your correlation, the accuracy, and all that stuff. But anyway, I'll post this on my YouTube channel, and I'm going to link it to my How to Draw Almost Anything web instance, and otherwise it's gonna be a cool project. So again, let me just clarify once. Is I have a Gumol, which is a molecular dynamics simulation engine that I wrote in Rust. That is a variant from Gumol, which is a Rust-based molecular dynamics engine. Then I bring those it outputs a file, and then that file is input into the MicroDrop, which is this application. So then you take that and you're trying to correlate between through outputs from the Nuclera system as well as Gumol's simulation to see how close they are to gain insights. There is also a visualization engine for another time. Anyway, that's what we got, and I will see you next time. Peace.